Shortcuts. If you're using a fairly modern operating system, this is probably something you've had some amount of exposure to. But what if I told you that the shortcuts that you typically get, at least in a Windows operating system, is fairly simple and that there are actually more powerful cousins of the shortcut available? Well, in today's Random Wednesday episode, we delve deeper into these alternatives. Hello and welcome back to another Random Wednesday episode. In today's video, we're going to start off by dissecting the basic shortcut that we get, just by right-clicking. We'll try to understand what's actually happening under the hood when we do that. Then we'll move on to try and understand its cousin, the symbolic link, to see what kind of differences that actually brings about. So with that said, let us go ahead and jump in to take a look at the most basic shortcut. Now, you know how the most basic shortcut works, right? You have a file, it could be of any format, in this case this is a text file, and of course you could simply right click and drag, release, and say create shortcuts here, which, well, gives you a shortcut to the file itself. You can double click on that and again, you're accessing the same file. That's pretty simple. The basic shortcut gets its job done without any fanfare. At the end of the day, a shortcut is just a file, in fact with a .lnk extension, and the idea is that within the file itself, it contains a bunch of information that tells your computer what to do. When you open it with, say, Windows Explorer will read the file, realize that it is in fact just a shortcut, and redirect you to the appropriate location. So that's all well and good, but there are some drawbacks to doing things this way. You see, because this pattern is involved, shortcuts are generally designed to be worked with by the user. That means it's the user choosing to open the file and interacting with it. In other words, if a program wants to use a shortcut, it can't. It's just going to see the contents of the shortcut itself, because again, there is no translator involved this time. We can use a very simple demonstration to show this. Now, you can actually open a file by dragging and dropping it into, say, Notepad, for example, to look at its contents. But here's the deal. If I take my shortcut file and give it directly to Notepad to open, well, you're not actually going to the file itself. Instead, you are seeing this garbled mess, which is the binary contents of the shortcut file. This is the .lnk format at play. So yeah, it turns out this is not a viable way to do shortcuts if you want any program to interact with the shortcut, and not just the user. So we introduced the symbolic link, or shortened to a symlink. You see, a symbolic link is slightly different from, your standard shortcut because it affects path resolution. What this means is that you could actually have a symlink and use it in a path as if it was just a normal file or folder. When you do this, the operating system translates all of the symlinks on the fly and sort of automatically and transparently redirects you to the appropriate location. This is huge because what this means now is that having a link becomes completely invisible to whatever program it is you're using. The programs don't know and they don't care. They're just going to use the path as if it was any old path, not even realizing that there is a symlink hidden in there. Let's take a look at how we can actually implement this in Windows, and we'll give it a spin to see how it works out. So we are back on our desktop with our file here. Let's go ahead and attempt to create a symbolic link to this file. Now, unfortunately, in order to do this, you do need the command prompt, and depending on what version of Windows you are using, you may even need to have administrator rights for the command prompt window. So I'm going to go ahead and press start, type CMD here, which will of course show up the command prompt option. I'm going to right click on that and say run as administrator. And you should end up with an admin command prompt like this. As mentioned, this is pretty version dependent because on another computer in which I've tested this on, I did not have to open the administrator command prompt. So your mileage may vary here. Anyway, I'm going to go ahead and jump over to my desktop by using a cd command. Cd means change directory, right? So I want to jump to my desktop like so. And we are all ready to go ahead and create our symbolic link. To do that, the command you use is make link. Then you specify the name of the file you actually want to create. So I'm going to call it symlink.txt. And of course, we need to specify what file we actually want to link to. So we'll give the name my file. When you press enter, it should say symbolic link created, and the symlink is created here. Let's see what are the differences now. If I were to double click on this, well, that's just the contents of my file, right? Nothing new here. But here's the interesting thing. If I were to open a brand new notepad window, dragging and dropping the symlink here opens up my original file this time. That's right, when Notepad attempts to open this file, it is silently and automatically redirected to my original file. You can almost imagine it as the symlink is pretending to be a file on its own. When accessed, it is sort of quietly redirecting you to the original file. It is completely transparent. I can try to browse to that file by typing in the file path in my run dialog box like this, right, like so. And if I were to try and open it, it will correctly go to the right place. So that's the power of a symlink. Again, the simplest way to understand this is that it is so-called pretending to be the actual file. And what that means is that any program can actually use the link. As long as it can be formed into a normal file path, then any program can interact with it. That is the magic of a symbolic link. You can also create a symbolic link to a folder. So the syntax is quite similar. You want to do make link, but this time you want to specify that I'm trying to work on a directory. That is the classic name for, well, what we call folders today. So put in the /d command switch, then give a name to your symlink. So let's call this link to folder, and of course specify the actual folder you want to point to, and there you go. That would be the symlink to your folder. So to show that this works, I'm going to go into my link to folder version, and I'm going to go ahead and create a new file here. So let's call this file A, open it up, write some text. This is file A, and save. Now again, remember, we are doing this in the folder called link to folder. It looks like that is the current folder that we are sitting in. It looks like we are putting a file in that folder. But in fact, when you go to my folder, you will see that, well, the file actually lives here. Again, I can access the file by just treating this as the folder name. I can even ask my command prompt to go and fetch the file, but using the name of this folder rather than the actual folder name. So I could say go to C, users, user, desktop, link to folder, file A, and it will still give me the contents of file A. So it's like I've substituted the actual folder name for the symlink folder name. And that still works exactly as you would expect. And that, ladies and gentlemen, is what is so powerful about symbolic links. Again, this whole process is transparent to whatever app that is trying to use the path, right? It just sees a path and uses it. Now, turns out this is not the only alternative there is to, well, your typical shortcuts. Another cousin of the symlink is what is known as the hardlink, and this one goes even deeper. A symbolic link links to a file or a folder, right? But a hard link takes this one step further by linking directly to the data on the disk. I am sort of glossing over some of the technical details here, but the key takeaway here is that the hard link will point to some location on disk where the actual data actually exists. Essentially, you're creating another entry point to a file that already exists. The simplest way to see this would be that every file is essentially a hard link. It acts as a portal to some data that is being stored somewhere on disk. And what you're doing is you're just trying to create one or more additional entry points to a same set of data that you would find on disk. So let's see this in practice. Again, we're going to go through the same process of saying make link, but this time we're going to go /h, and that means we want to create a hard link. Again, name your file hardlink.txt, and then name the source file, which is of course my file.txt. Run the command, and notice something interesting. This icon here doesn't even have the shortcut symbol because, well, it's not really a shortcut. If you open up this file, you see some text. You can go ahead and edit the file if you want to, and of course, the changes will be reflected in the other file as well. So these two files are still linked together, right? We could establish that. Now, it may not be so obvious what's the difference between, well, a hard link and our standard symbolic link. So here's a demonstration that's going to make things crystal clear. We already have our hard link. Let's go ahead and try and create a symbolic link again. So of course, running this command creates a shortcut here. Now, what do you think is going to happen if I were to actually delete this file? In fact, let's go ahead and do this, right, with a permanent deletion. Of course, the symbolic link no longer works, for the very simple reason that the symbolic link points towards my file.txt, which is no longer there. However, a hard link is going to work just fine. And this shouldn't be too surprising if you've understood the concept behind how this works. Remember, if a file simply points towards some source of data on disk, then getting rid of this file isn't going to do anything, right? The original data is still there, and we can find our way to it by using the hard link. So the whole chain is still complete, we can still access our data. So in fact, when it comes to the deletion of files, we would consider a file to be deleted when you can no longer find your way there, when it is so-called dereferenced. If no hard link is pointing their way to that file, that means that, well, nobody cares, nobody's using this file anymore, right? So we can get rid of it. Up to this point, we've seen our basic shortcuts, we've seen symbolic links, and we've seen hard links. They have, subtle differences, so let's go ahead and compare them and talk a little bit about their differences in terms of what use cases there are. First and foremost, a shortcut can point towards anything, but it cannot be used as a part of a path, simply because it's just a file, right? It needs to be understood by a file explorer. So this is the most simplest and is the most intuitive way. But there are drawbacks in the sense that programs are not able to interact directly with them, and that, of course, they don't actually carry useful information. There is actually a story here to be told. For those of you who don't know, I am an instructor and lecturer. I teach at physical institutions, and sometimes when we get students to submit their work via online portals, students submit link files to me. So that is the shortcut file that I've shown you earlier on, right? That little file that has all that binary garbage in there. That's not the actual file, and I can't open it. I can't grade their assignments. So this is something interesting that, despite all the intuitiveness of having a shortcut file, this is where it falls short, because it represents the file in many ways, except it's not the file itself. You don't want to back that up, you don't want to transmit or store that anywhere, because again, the actual information is not contained in there. Anyway, going back to our picture, we then move on to talk about our symbolic links, which, as mentioned, their greatest advantage is that they can be used as part of a path. They pretend to be a file, so as long as you write out your path properly, you can use this with any application. This is particularly useful because some applications actually have hard-coded paths. What that means is, they expect to store or retrieve information on a particular folder. And if you don't want that stuff there, you can use a symbolic link to trick it into saving information elsewhere. In fact, that is the whole motivation of this particular video, because I ran into this problem. Sometimes, especially when it comes to file and folder structures created by programs, you may find yourself with extremely long file paths. Examples, of course, include the npm node modules folder, which can be gigantic, with file paths that are buried so deep that you may even have issues deleting that stuff. Because the symlink acts as a drop-in replacement for, well, a big chunk of the file path, you can potentially use that to work around the problem. Of course, the issue is that they still point to a file, right? So it's entirely possible that the links themselves get dereferenced when the original file or folder has been moved or renamed or deleted. So that's important to think about. So a hard link is the one that sort of does the most things, but also has several limitations. Because of the way it works, and I'll refer you back to this picture here, it does not make sense to have hard links refer to files on other drives. So hard links will only work with files only, and just the files on the same drive. You cannot use it to refer, say, from your C drive to your D drive, refer to a flash drive or so on. That will not work. But of course, what's cool is that we are not dependent on the original file. You can delete it entirely or rename it or move it to another folder, and there will not be any issues. Also, because the hard link points to the raw data, it is completely okay to copy it to another drive or upload it to the internet, because the original source of data remains accessible. Other issues include its slightly misleading appearance. It may look like a duplicate file, but it is not. Modifying the file will affect all other so-called copies of the data, and when using it for backup purposes, you have to be careful. Backing up implies redundancy of some sort, which Hardlinks do not provide. To be really safe when it comes to backing up data, you'll want a separate copy of that data in a separate place. A hardlink does not do that because at the end of the day, there is only one source of data. It's just multiple things pointing to that source. The only thing it can protect against is accidental deletion. If you delete one hardlink, you still have another hardlink. You can still find your way back to the content. So that's all it guards against. And what that means is it will not protect you against things like, say, disk failure. And while Symlinks are great, there are some generalized, subtleties, I would say, about how Symlinks actually work. For the most part, in our Symlink-free day-to-day life, the general assumption is that having a different file name means the two files are distinct, they are different. Once Symlinks come into the picture, this is no longer true. Two completely different file names can be referring to the same thing. Because that assumption doesn't hold anymore, doing operations like file cleanup and deduplication now needs more steps. You need to consider more factors before you can determine that two files are duplicates of each other. In addition, there's a very interesting dilemma involved here. If I've created a file that is a symlink and I say delete it, do I mean delete the link or the file it's linking to? There are two ways of looking at this, and neither of them are great. I would say the more intuitive way, at least when we use a Windows GUI, is that deleting a symlink will delete the link itself. But that then contradicts the behavior of a symlink, right? Because the whole idea is that whatever you do to a symlink is going to silently transfer you to the file in question. So we end up making an exception for deletion. Windows, at least the later versions of Windows, does things this way. If you attempt to delete a symlink, the original file stays intact. Personally, in terms of usability, I think that's probably for the best. However, the more classic behavior stays true to what a symlink is. If you attempt to delete a symlink, you are going to be silently redirected to the original file, and the original file gets deleted. What this means, of course, is that again, you need to think carefully about what you're doing, because one misstep and you lose your original file. For operating systems that do this, you will typically find a special unlink command that is designed to break the link. So deletion and removing links become two distinct operations. Another issue with Symlinks is that if you don't set it up correctly, you could end up with a circular reference. So one symlink somehow finding its way to another, which then finds its way back to itself, creating a loop. This, of course, is probably only going to happen when you use Symlinks extensively, and I suppose that's the reason why, Windows doesn't allow you to do Symlinks very easily. Sticking to the standard shortcuts has its advantages, and that is, of course, thanks to the fact that it is generally intuitive. Apart from, uploading the wrong file like I told you just now, the standard shortcut doesn't really give you much room for error. So, that's shortcuts, Symlinks, as well as hardlinks. There's actually one thing I haven't really talked about yet, and that is, what are you going to do if you have some symlinks that you want to create on a remote device? This is slightly beyond the scope of, this video today, so I'll just very briefly mention it to you. If you're going to link to a file on another computer, then there's an additional challenge, because when your operating system is translating the link, where does it go? Does it go to the local system, which may also have a C drive and so on? Or does it go to, the remote system, which also has a C drive? If the link is being translated on your local device, you will find that generally the link will point back to your local device. So if that's not what you want, there is another feature called junctions, which is sort of the even lower level version of a symlink. When a junction is being encountered on a remote device, it is translated, it is so-called unpacked on the remote device, and as a result, you actually get back a valid path, whereas a symlink will always point to your own device. So if this is something that ever crops up for you, then you would want to use a junction. A junction is built in largely the same way as you would build a symlink as we've seen earlier. The only difference is that you would use the /J switch. Again, this is somewhat beyond the scope of this particular video. The main thing I'm trying to point out here is that Symlinks can be very useful, especially when it comes to, having to trick a program. And of course, its cousin, the Hardlink, is of technical interest. Anyway, I think this video has gone on long enough, so let's go ahead and wrap things up. Thank you very much for watching. I hope you've gained some insight today. But until next time, you're watching 0612 TV with NERDfirst.net. Thank you very much for watching. If you like my work and are feeling generous, you can shoot me a one-time donation on PayPal or sign up for a recurring one on Patreon. Of course, you can simply like, comment, and subscribe. You know the deal. For more videos, links to my channel and a related playlist are on screen. Thank you for your support.